I know we have a lot of absences today, and then Eric is testing. So, Perla, who's always talking, isn't here. Janelle's, who's usually talking, isn't here either. So I want to see a lot of you all who tend to stay pretty quiet speaking up today. So first thing, we're basically Tyrone, who is always talking, don't worry, y'all. He's got you covered, but I'm not going to make him talk the whole time.
What about me?
Oh, you're here too? I hadn't heard you yet. You were so silent.
I can't even see the whole question. Never mind. It was zoomed in. Sorry.
Okay. So very basic stuff here. We're just going to label this circle. So what is the red line called?
So the red line
Radiation.
is radius.
Radius. Good.
The blue line is like diameter or something.
The diameter.
Yep. And what about all the way around?
A circle.
Circumference.
Circumference. Good.
Just circle.
Okay. Pretty basic stuff. Now the radius and the diameter are meeting up at this point. What's that point called? It's very simple. Don't think too hard about it.
Midpoint.
Even easier than that.
The center of a circle.
Yeah, it's the center. It's the center. So very basic information about circles. Any questions on those definitions? Cool. Okay, so I can skip through these a little bit, but I did write them down. You don't need to write them down because I know that pretty much all of you already know this, but you can if you want to. So the radius of a circle is the distance from the center to the outer portion. The diameter of a circle is the length that goes through the center and touches both edges on the outside of the circle. And here's one pretty simple formula that we use because the diameter is just 2 times the radius, right? So here's one radius. Here's another radius. So the diameter is just twice of the radius. Any questions on diameter? Okay. Then we got circumference. So circumference is the distance around the circle. And we also have an equation here that is going to come in handy. So please, if you don't know this one, because now we're getting a little bit into it, go ahead and write it down. But the circumference is equal to pi times the diameter. Now there's another way to write this because what did we say about the diameter? What's the little formula for diameter?
2r. Wait, is it 2r?
Yeah, 2r. So another way to write the same formula is that circumference is 2 times pi times r. 2 pi r.
That made it a little harder, but okay.
Simply because the diameter is 2 times r. So that's where that comes from. So in this circle that I've got here, if the radius is 5, what would be the circumference?
Wouldn't that be 10?
10 pi. So the pi, we kind of treat it a lot of times like a variable, like x or m or n, simply because we know that pi, what is pi? What does pi equal?
3 point for something, I forgot.
3 point what? Who remembers?
I know Daniel remembers.
Daniel, you remember what pi is equal to? Are you guys in my classroom right now? Because if
It's
you're in
like
my classroom,
3.5461 or something like that. I forgot.
Tyrone's
I
got
know
it.
it starts with 3.1.
So it's 3.1415 9.
We all know
9,
Tyrone did not
2,
know.
6, 5,
He
3,
used to calculate.
5. It's very long, very, very long. So since pi is a very long, infinite number, does it have any patterns?
Well, no, unless you multiply by 2.
Even if you multiply it by 2, it's not going to have any patterns because the numbers are kind of random. What type of number is pi? See if we remember any algebra.
A decimal.
It's a specific type of decimal. I feel like Emily might know this. She's really good at memorizing definitions. I'll list out some options. So there's a lot of different types of numbers. We have integers, we have fractions, we have whole numbers, we have rational numbers, we have irrational
Rational.
numbers. What is it?
I think it's rational. I'm not sure. I think
Not rational, it's
that's not helping.
the opposite of rational.
Fraction?
It's the
What?
opposite of rational.
This is confusing.
Oh my God, it's really not. Y'all took the EOC. I know you've seen this word before. No?
I am lost. Are you serious?
Are you serious? I'm the one who's shocked here that nobody could remember that. That is embarrassing.
Or it's gonna put some
irrational
radiation in
number.
my brain.
No, it's you not practicing and you not remembering things. Caring too much about things that don't matter. Tyresha, what's up? You got locked out? Okay, 1 second. By the way, we've been testing all week, Tyresha, and you haven't been here for it, so you're only going to do part 1, okay? I'm not going to give you part 2 because you're not going to be able to finish by today. So keep working on part 1. If you don't finish it now, I'll have you finish it during 8th period, and then you'll be done, okay? All right, I just unlocked you, so you can go back. All right. Cool. Okay, so since pi is an irrational number, we don't really use it. We kind of leave it as pi. Okay, any questions on that? Cool. Okay, so if the circumference is 5, or sorry, if the radius is 5, it's very easy to calculate the circumference. And okay, moving right along. Then we've got area. So the area of a circle would be everything inside of the circle, okay? So that's the difference. Remember, circumference is all the way around. Area is everything on the inside. And the formula for that is A equals pi r squared. Pi r squared. So go ahead and write that one down as well. You've probably seen it before. So go ahead and using the area formula, tell me what would be the area of a circle with a radius of 5. Sure, I'm just going through that first problem. What would be the area of a circle whose radius is 5? And just give me 1 second because I have a student here. Hi, Pierrette. You, Missy, you haven't been here all week, so you haven't been able to start your test. So you're probably not going to be able to finish it today. However, I'm going to go ahead and put you in a breakout room, and I want you to start with part 1. You should already see it on Performance Matters. So just part 1, try your best to finish it, and then we'll see if you're able to do part 2 during next period. I don't know if you're going to have time for part 2 today. And if you can't do part 2, unfortunately, I can't give it to you next week because today's the last day. Okay, so just go ahead and start part 1, see if you can finish that. If you do finish it, you can go on to part 2. And go ahead and go to the breakout room. Good luck. Okay. These algebra kids, man. They don't
We
make
were
them like
once
they
like
used
that.
to. So in problem number 1, find the area of a circle with a radius of 5. What would that be?
I'm gonna send it to you privately. Hold on.
Okay.
Wait, do I have to round it up to like the nearest or just leave it at that? 3 decimal
Remember,
points.
leave pi as pi. Pi is just pi. No need to
Okay.
use it.
Isn't it pi to 5 squared? Or
So it'd be, okay, so it'd be pi times 5 squared.
25 times 5,
So it'd be 25 pi.
or that.
We leave it like that, 25 pi. Again, we are not going to use it unless they tell you to, okay? If they say to approximate it using 3.14, great. Then you just go ahead and you put that into your calculator and you just multiply 3.14 times 25. Now, what do you get for that?
Oh, once you solve it,
Mm-hmm.
the whole thing,
Up to 2 decimal places.
78.539.
So would it be 5.3 or 5.4?
54.
5.4. So that's the approximate area, but since 3.14 is an approximation, that's why we tend to just keep it as pi. It's more accurate that way. Find the area of a circle with a diameter of 16. What do I do here?
Divide the diameter by 2.
Good. If the diameter is 16, what's the radius?
8.
Good. So you just have to be careful. If they give you the diameter, you want to make sure that you divide it by 2 before you use it. So what would be my area?
That will be, what's the name? 8 squared would be
Mhm.
64. And wait, solve it too?
Nope, we're going to just leave it
Okay.
64 pi. So any questions on calculating the area of a circle? So far, nothing too crazy, right? Any questions at all up to this point before I kick it up a notch? Okay, cool. All right, maybe these are new words. You may not have seen them before, but here we go. Can I have a volunteer read? What is the sector?
Tyrone.
Yeah, I've heard a lot from Jalen. I've heard a fair amount from Tyrone. Maybe Rios? Can you read? Rios or Samaj? Let me know if you're here, because if you're not, I'm gonna kick you out of the Zoom. Can I just get confirmation from Rios and Samaj that you are in fact listening to me right now?
I have a question.
Yes, Jalen.
I go use the bathroom real quick.
Yeah, go quick. So Rios is not here. Samaj is not here. You have 5 seconds. I'm going to kick you out. 5. Oh, Rios is here. Samaj, are you here? 5, 4, 3, 2, 1. Goodbye. Rios, please go ahead and read the definition of a sector. I'm waiting. Y'all, we're not playing this game today. Rios, you have 5 seconds or I'm going to kick you out as well. 5, 4, 3, 2, and 1. Bye. RL, what's up? You got locked out or you're done? Yay, you're done. Awesome. You can head out. Thank you for getting it done.
Is that radius or radii? 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 How do you pronounce that?
Radii. Radii. That's how you say it. When there's more than one radius, it's 2 radii. Okay. Jalen, I'm going to have you read because I just had to kick out 2 of your classmates.
Bummer.
Bummer indeed. Go ahead.
Which one?
Sector.
Can I read both?
Sure. Yeah. Start with sector though.
A sector. Oh, okay. A sector is the portion of the interior. I can't read. Interior of a circle between 2 radii. Yeah, radii.
Mm-hmm. Radii.
2 sectors must have congruent center angles to be similar. An arc is a portion of the circumference of a circle between 2 radii. Likewise, 2 arcs must have congruent central angles to be similar.
Perfect. Okay. So there's kind of a lot in this whole situation. So a sector is just a portion of the circle. So you can think of it like a slice of the circle, like a slice of the pizza.
Pie. Same thing. Pie, pizza, same thing.
Same thing.
No matter.
So go ahead and you should be writing these down, but the easy way to remember it is that sector is a slice. And then an arc is the portion of the circumference. So let me go ahead and actually highlight the arc because I didn't color it. So this right here, arc, is a portion of the circumference. So you can think of the arc, if you have a pizza, what would be the arc?
The arc. How big would the pizza be? Something like that.
Well, if you take out a slice, look at where I highlighted it. What part of the slice of pizza is the arc?
In between the 2 radiuses.
Yeah, but on a pizza. What's this portion of the pizza, the one that I highlighted in pink?
Pizza slice that got cut.
How about the crust?
Oh my God. Yo, I swear. I get some of the easiest stuff wrong.
Rios, I need you to understand that when you're in class, you're in class. You are in school right now. So if something's going on at home, you got to let me know because I can't, you got to let me know. I'm not there with you. I don't know what's going on. I can't just sit here calling your name, waiting for you to speak and making the rest of the class wait for you. You can't just leave your computer without letting me know because you are in school right now. Can't just leave my classroom, right? If you were in school, you can't just walk out of the classroom without telling me why you're leaving. It's the same rules. And I expect that goes for everybody. I expect you to tell me whenever, if something, I understand if you got to go do something, if you got to help someone out at home, but you have to tell me. You have to tell me. Okay. So we have a sector and we have an arc. Do I have any questions on what those two parts of a circle are? Okay. So here's one more definition and then a new equation, a new formula
What
to
is
remember.
that?
Have I explained it yet?
No, but just looking at
Okay.
it looks hard. I'm sorry.
Wait for me to explain. Central angle, who can read? Let's have Tyrone read because you haven't read yet. Hold on, let me use a better color. Okay, go.
From a central angle,
Mm-hmm.
a central angle in a circle is formed by two radii. This angle lets us define a portion of the circle's circumference, an arc, or a portion of the circle's area, a sector.
Perfect. So the angle is just exactly what it sounds like. It's the angle that you get when you have a sector. So just when you take out a slice of pizza, it creates an angle, right? And you can think of it like this. Okay, so what happens is you can make this kind of 3-level proportion. There's 3 parts of this proportion. Usually with a proportion, Elvis, what's going on? You got locked out or you're done?
I'm done.
You're done? Cool. See you later. You can go back to class. So usually a proportion only has 2 sides, right? You got your left side and it's equal to the right side. Pretty simple. However, with this proportion, it's got 3 sides because there's 3 things that we can compare to each other. So let's take a look at what we have. So the central angle over 360. Why do you guys think it's over 360? What do you know about circles and the number 360?
They don't. Well, the whole angle around is 360.
The whole circle all the way around is 360. So what this is doing is taking just a part of it over the whole circle. It's a part over the whole. What about the arc length? We know that the arc length is just one slice, one part. But if you go all the way around, what's that called?
The circumference.
The circumference. So again, over here, we have part of the circle over the whole circle. And then finally, the sector area, so the slice that you took out of the circle over the whole circle. One more time, we have a part over the whole thing. So all 3 of these ratios will be equal to each other. And that's going to be very helpful if we ever need to find a missing value of either the angle or the sector or the arc. So go ahead and make sure we have this equation, this 3-part proportion written down. Okay, any questions on this slide?
So all of that is well. Turn on, you're unmuted.
Should I get jumper or shotgun, MC?
Tyrone,
Tyrone.
what are you talking about? What's jumper or shotgun? Doesn't sound like it's related to math. It's okay. I can tell Miss Crusetta to check on you. All right, so let's go ahead and set up one example. So here we go. In the figure above, O is the center of the circle. If the area of the circle is 16 pi, what is the area of the shaded region? So let's go ahead and look at our 3-part proportion. And let's figure out which, because when you have a proportion, you only want to use 2 out of the 3. So I'm going to highlight what we know. We know that the area is 16 pi. We're looking for the area of the shaded region. Now, what is this called, this shaded region?
The sector.
It's a sector. Yeah. So we're looking for the sector. So which of my 3 ratios can I use for that part?
The first one, and do we need circumference? Because we already know. No, the area of the
No,
circle.
right? Because
No.
it doesn't say circumference. So we can use this portion, the sector area, and the circle area. And then, why did you say the first one? You're right. Why did you say it?
Because the arc length, what's the name? That's for the outer triangle.
Mhm.
So we got to find the area because for circumference that's outside and the arc length is on the outside. So we have to find what's on the inside. So
Yeah. And
the
do we
central
know,
angle.
what do we know about the central angle?
It's in the center. So
Do we know how
about
much do we know how much it measures though?
Oh,
There, Emily's got it. It's 90 degrees. How do we know?
it's a fourth of the triangle.
Yeah,
Wait.
right. It's a fourth of the whole thing. It's a right angle. So there we
That
go.
gives out a lot.
So those are the 2 parts that we're going to use. So we know that the central angle is 90 over 360. We're looking for the sector area, so we don't know the sector area. But we know the circle area is 16 pi. So we're gonna use everything else that we know in order to solve for x. And this is just another proportion. So we can solve this like we always do,
I think I know what it is.
cross multiplication. So 90 times 16. You can use your calculators. 90 times 16.
304.
304 pi equals 360x. Now we just divide both sides by 360, and what do we get? Wait, hold on. 90 times 16. Try again. What's 90 times 16?
Oh, wow.
How'd you get that number? I don't know.
I don't know how did I get that.
1,440. Okay. Now we can divide both sides by what? Divide both sides by 360. Good, because we're solving for x. What is 1440 divided by 360?
I don't know. Let me get my calculator out.
Can you say that one more time?
1440 divided by 360.
Wait, 14.
I think it's
Oh,
like
that's 4.
4 or something. It's 4.
That's 4.
It's 4.
4. And is it just 4? 4 is
4
my
pi.
answer? Okay.
Yes, it's 4.
4 pi. Don't forget that pi.
Oh.
So the sector area is 4 pi.
I think I figured out another way how to do it.
How'd you do it?
Since that one angle, the whole circle is 360, right?
Mhm.
And we're trying to figure out what's that one angle. Since it's 90, that's a quarter of the circumference of the whole circle. So I just divided 16 by 4, and it gave me 4.
Easy, right? So sometimes it's a little easier to do it that way. But the reason that the cross multiplication method is useful is because sometimes it's not as obvious. So we'll see. We'll do a few examples together. So we'll see if it works each time or no.
Only for the 90-degree angles.
Yeah. So here's another one. So we know that the length of BC is 3/10. So hold on. BC is 3/10 of the circumference of the whole circle. So let me highlight that because this one's a little bit different. So BC is 3/10 of the circumference. Okay. And then we're looking for the value of x. So we need the central angle. So which two of the three ratios am I using?
So I think the first and the second one.
Yeah,
we
the
don't
first
need-
one,
No, we don't need that.
right. The first one, because I'm looking for the central angle. And then the second one, because I have the arc. Okay, so those are the ones we're going to use. Give me 1 second, guys. Hi, Zaria. I'm going to go ahead and put you in a breakout room. And when you get there, just go ahead and work on your test. Finish it as quickly as you can. Try and finish it by the end of this period, okay?
I think she's disconnected from audio.
Yeah, I'll message her. Okay. All right, so here we are, continuing. So we're using those two parts of our triple proportion. Now let's go ahead and make sure that we set it up properly. So central angle is what we're looking for. So that's x over 360. And we know that the arc length is 3/10 of the circumference. So they actually give us, because let's say if the whole circumference is 10, how much is the arc length?
3.
Is 3, right? So we can basically just go ahead and put in that fraction. So it's not quite as easy as the previous problem to do like in your head. So if you ever, if the numbers are easy enough to do in your head the way you did it before, Jalen, go for it. But if they're a little bit more complicated, like this one, I would personally do the cross multiplication method because that one never fails. So here we
But
get
it
10x.
only, oh, my bad. You're speaking. My bad.
Oh, it's okay.
But it
What were
only
you-
works for 90-degree angles.
Yeah, because that's an easy number. 1/4 is pretty easy to do. And what's 360 times 3? We get 1080. Divide both sides by 10. I get x equals,
I got 108.
108. Yeah. And it's 108 degrees.
Big boy angle.
Big boy angle. Questions on this one? All right, let's do a few more. I have like 3 more. We're just gonna keep practicing this because then you're gonna have to try it on your own. Yes, Tyrone, we got 1080. 1080, not 1808. Got it? Okay. All right. Then, here we go. What fraction of the area of this entire circle is the area of the shaded region? So now we're looking for the shaded region. What do we call the shaded region again?
Sector.
The sector. So we're looking
The
for the
inspector.
sector. We know this. Okay, and then what do we know about this?
The angle of
What
the
is that
shaded
called?
region. Center circle. Center angle.
Central angle. We know that the central angle is 150. So which parts of this proportion should I use?
The sector area over circle and central angle over 360.
Perfect.
Xbox 360.
Okay, let's do it. So we know this is 150 over 360. We don't know the sector area, so that's our x. Do we know the circle area?
No.
Hold on a second. Oh, I see. Okay, read it carefully. What is it asking? What's the question actually asking us for?
What is the fraction of the area of the entire circle? Oh,
So we're just looking for the fraction. So we actually don't need to find the area itself. We just need to know the fraction. So basically we can reduce the fraction that we have over here and simplify it, and we'll get our final answer. So what is 150 over 360 when we simplify it?
I say we can divide that by 3.
By 3? Top and bottom by
Yeah.
3.
Yes.
What does that give me?
That's if I can mental math properly, that is 50 over 90, I think.
50 over 90. Good. Can I simplify that further?
All right, time to go into my deep parts of my brain so I can figure this out. Tyrone, you're up. I helped you enough.
50 over 90. This one's easy. There's an easy way to simplify. Ow, I just banged myself. 25 over 45. Okay, so you divided both of them by 2. Can keep going though.
Five.
Yeah, divide both sides, both top and bottom by 5. What do you get?
I think that's 5 over 15. No. 9. No. Yeah. I keep doubting myself.
There's the fraction. 5/9. If the length of the minor arc, now, here's a distinction, because technically, here's my arc. We call this the minor arc because what would the other one be?
Major arc.
Because you could go either way. So they told us, okay, it's the minor arc just to make sure that we are looking at the right part. So the minor arc, they're telling us now that that is 10. And they want us to know what is the circumference of the circle. So let's set it up. So can anyone, 360 divided by 3 is 120, not 90. Oops. You are right. Everyone thank Emily. She's smarter than Miss Lopez. We set this up a little incorrectly from the beginning. So that's 120, which means when you divide both sides by 3, you get 40.
Oh, wow.
And then final answer is 5 over 8, not 5 over 9. Oops.
Oh, wow.
Oh, wow. Okay. Sorry.
I feel defeated.
All right. Well, in this part 2, let's go ahead and set up our proportion. So where can I begin with? 150. So it's 150 over 360 is equal to, what do we know? It is equal to 5 over 8, but now we're actually looking for something. What are we looking for?
Let's go, Tyrone. You got this, bro.
Read the question over. What are we looking for? What's the question asking for? Read it again. What do we not know?
Starts with a C.
Tyrone, we're just matter of fact, read the question out loud, please.
Oh, is it the circumference?
No.
Circumference.
I'm just-
We're looking for the circumference. We don't know the circumference. We don't know the circumference. So where's my x going, on the top or the bottom? Remember, it's part over whole.
Bottom. Like, no. Yeah.
The bottom. What's on the top then?
The arc length.
The arc length, so 10. So just remember, it's always part over whole. And I need to make another, guys, it's Friday, I'm tired. I made another mistake. Over here, we divided it by 2. So this is 60, not 40. So the final answer is 12. 12. 5 over 12. Am I right now, Emily? I want to check before. Okay.
Defeated once again. This time it wasn't me. It was
Oh
you.
my gosh, this video is going to be so embarrassing to watch. So if you're currently watching this, Perla and who else is, and Janelle's, just, it's Friday. Don't make fun of me too much.
Comment
Okay.
down the laughing emojis.
All right. So now here's our proportion. Let's go ahead and solve it. 150 x is 3,600. Divide both sides by 150. What do we get?
What's 9 plus 10
19.
plus 5?
24.
Yes. I was going to expect you to say 21. I'll say plus 3.
24. Any questions on this one? So 5/12 is the fraction. You can think of it like the ratio is 5 over 12. And it helps us to find all the other. Careful, Tyrone, it wouldn't be 5 to 12. It would technically, it would be 5 to what? What's 12 minus 5? Yeah, it would be 5 to 7. Remember that ratios, when they're written that way, you gotta add the two numbers together. Yeah. Okay, here's another one. I want you guys to try this one on your own. Take a moment, set up the proportion, and see if you can calculate it on your own.
AC. If this was a triangle, it would be easier.
It is a triangle.
Well, we don't have the
Oh my God, I know what it is. This
You
is
got
so
it?
easy.
It's easy.
I just looked at it and I already got it.
Okay. All right, Tyresha, you can go. I'm going to have you do part 2 during period 8, okay? So go back to class and then you'll do part 2 when you come back to my class. Okay. I'll give you guys about 20 more seconds while I unlock these hooligans.
Who uses that word anymore? I'm not gonna lie, I use it a couple times.
It's a good word. Okay.
It gave me some Game of Thrones vibes.
Game of Thrones. Okay. Hooligans. Here we go. Which parts am I using? Or set it up for me. What do I write? Good. 120 over 360 is equal to okay, we're taking turns.
I didn't do my weather, so I'm trying to guess. Arc length. Do we need arc length? Yes, we do. No, sector. No. Yeah.
What are we
need that.
looking for?
Uh, x over 12. That what it is?
Just 12?
No, pi. Yeah, that.
12 pi. Good. Let me use my colors. Hold on. Y'all know. Okay. 12 pi. No, x over 12 pi. Sorry. There we go. Okay, so this is the part we don't know, but we do know that the whole thing is 12 pi. So now we go ahead, cross multiply. 12 times 120.
Well, I was gonna say it.
1440 pi. Oh, this looks familiar. Equals 360x. Now what do I do to both sides? Minus 360?
You mean divide?
And what's our final answer? 4?
I knew it. I got the same thing. 4 pi.
4 pi.
You wanna know how I knew it was 4 pi?
How do you know that it was 4 pi?
The angle 120. That's 1/3 of 360.
Mm,
And what's 12 divided by 3?
it's 4. That's good. See, that's what I was saying before. So some ratios are just easier to do in your head. Like this one, you did it just fine in your head. So, but it's important to know how to do it the other way because sometimes the equations are not quite as easy to realize what they are. Make sense? Let's do one more.
Si, senora.
Oh, wait, no, that's it. That's actually it. Okay, I actually want to do one that's not here that I just thought of that might come up when you do this on your own. So here's a kind of more of a challenge. What if the radius is 7? How would I figure this out? Say the radius is 7 and I'm looking. I want to know x.
Or trying to put the thinking cap on.
Iced tea.
I'm gonna need some iced tea after this.
So let's start this the same way. We start it the same way. How would I start my proportion? 12 over 3, 120 over 360. And on the other hand, we have the arc length, so that's x, over, what would need to go there? Is 7 the circumference?
That's the radius.
No, that's the radius. So we need to know the circumference. Well, can I figure it out?
Hey, so we don't count 12. That's out of the picture.
What? Yeah, we're not, just ignore this.
Oh, okay.
New problem. If the radius is 7, how can I find the circumference? Let's take a stroll through memory
Thinking
lane.
of something.
So this is how I know that my students are not writing down their notes. Just gonna leave you with that for a moment.
I knew it.
No, you didn't, because you didn't write it down clearly.
No, I did write it down, but
So why
I
didn't you
just
know the
didn't look
answer
at
when I
it.
asked for it?
I'm putting myself to a challenge. Trying not to look at my notes.
Well, you should be looking at your notes when you're learning a new topic. The circumference, C equals 2 pi r. So let's go back. C equals 2 pi r. What would be the circumference?
$14 pi.
14 pi. Now we have everything we need. 14 pi. Go ahead and find our final answer. And keep your final answer as a fraction. You can say it publicly. So you got 1680. When you multiply 14 times 12 is times 120. Good. 1680 equals 360x. Divide both sides by 360. And okay, you get 1680 over 360. However, can we simplify that? No? I think you can. What can you divide top and bottom by? Or what can you knock off both of them?
10.
Yeah, knock off the 0 first. So we got 168 over 36.
A bigger number is 12. Hold on,
12,
my-
let's see,
my mom is working.
168. Yeah, what's 168 divided by 12? 14. So 14, and then 36 divided by 12 is 3. 14 over 3 pi. So if they don't give you the circumference, you can always find it from the radius. You could also find it from the diameter. But what do you have to remember to do if they give you the diameter instead? What do you have to do to it before you use the formula?
Say that one more time.
Sure. Let's say new problem. We're not going to do it, but let's say they give you this. They say, okay, the diameter is 10.
Oh,
We have to divide it by half,
yeah,
by 2,
that.
in order to find the radius. And then once you have the radius, you can find the circumference. So now we have 20 minutes And I want you guys to go ahead and go on to Khan Academy. I'm about to release these 3 assignments. 2 are easy, 1 is a slightly more challenging, but the area of a circle and circumference of a circle should be pretty easy. Those should not take you more than like 5 minutes each. So go ahead and get started on them as soon as they come up.